house. Two of my kids had birthdays last week, so we had 3 birthday parties this weekend on this 24-hour period. It's complete chaos. It's a lot of cake, yeah. My oldest turned 8, and she's a competitive gymnast. So the 4 girls that have been on her team since she was 2 did a sleepover Friday night. So we had just a little tiny cake, and then we had my 2-year-old's birthday party in the middle of the day. So we had a whole dinosaur cake for that because dinos are the world right now in our house. And then my 8-year-old school friends came over later in the day, and we had 7 more 8-year-olds running around the house. And we did a cookie cake for that one. So a little bit of variety. But yeah, there's a lot of a ridiculous amount of food in our house right now, left over from 3 different parties. So we're just coming down off the sugar high, and it's all good. Couple of things coming up this week. This is week 6 of 14. We do 14 weeks plus the 2 days before Thanksgiving, and then finals. Okay. So this is week 6, but this is the magical week of calc readiness. I know some of us have put off calc readiness for weeks and weeks and weeks. It is not, I don't have control over this. This is not my rule. This is a departmental rule that you need to do this. So we need to, if you do not have at least 17 on that in that at the moment, you need to go and attempt to take that at least once this week. There's an opportunity each day for you to do so at various times. The schedule, I believe, is right back there on the back wall, but I believe Ms. Vance has been sending out emails every so often, right, with the schedule and where to do things. You can go ask her questions. If you're still struggling with certain types of problems, she can access and see what you got right and what you got wrong and those kinds of things. So she can help you as well. And I can do that as well too if you pop into office hours. So make sure that we take care of that. In addition, this week you have an exam 2 is on Friday this week. Okay. Exam 2 is on Friday. The practice exam went up on Friday, so it is there and available for you. There's a couple of questions I know that people freaked a couple people out because they didn't look exactly like things we've done in class, and that's okay. They are very similar to things we've done in class. And I am happy to go over questions that you have about that, either one in office hours, or if Wednesday, I'll take any and all questions related to this practice exam as well. Okay, so once you work on some of those, come see me, get help, do whatever you need. But the 2 that people were having trouble with were the find the point for which the function has a horizontal tangent line. I think we talked a little bit about that on Friday. A horizontal tangent line means that the slope has to be 0, slope of the tangent line. And that means that you're looking for the points when the derivative is 0. So you're taking a derivative, set it equal to 0, solve for x, okay, for that question. In number 3, you're finding the equation of the tangent line to the curve. Remember that the derivative represents the slope of the tangent line. So you're going to take the derivative of that function. You're going to use the x value of the point to plug in and get a value for the slope. And then you have the corresponding point. For letter B, you don't have the y value, but if you plug in that x value into the function, you'll get the corresponding y value. So then you need your slope and a point, and you can plug that all into the point slope formula or the slope intercept formula to get yourself an equation of the tangent line. Or in more detail if we need to. All right. This is not the correct one, but those were the same 2 questions that are on your practice exam. All right. Friday's quiz. We took a quiz on Friday. Also, by the way, on that exam, you may use same rules as last time. So you may use a calculator that is not your phone. You may also use a 3-inch by 5-inch note card with any handwritten notes on it that you'd like. Okay. All right, friends, let's talk about this quiz. This did not go as planned for many, many people. Okay. Did we not study these? Did we? Because in class, you guys seemed to rock them, and I was like, "Oh, we're moving on." And then all of a sudden, sorry, gets the quiz and we struggle. So watch out for that. Some of it has to do with the fact that we're misinterpreting. Our trig seems to be a little weak, which is both indicative on the calc readiness exam and the way we're using trig functions here. Okay, so I'll talk about that in a second. And yes. You don't write limits. That's NOT means notation. Same rules apply. If you're simplifying something and you're writing your limit down again and you still have x's, the limit notation needs to be there. Needs to be there. All right, so let's be clear about a couple of things when it comes to trig functions. Okay, let's talk trig. All right, when I write the sign of 5x, this does not mean that this is sine times something, okay? This means nothing in the world of mathematics. Just some kind of functions in here, I don't even know. There, because this isn't anything. It's not anything, right? Because sign tells you to do something. Sign is a representation of something, it's a set of instructions, okay? But if you don't know what you're operating on, then what are you doing, right? So this doesn't make sense. So this is called, what comes after your sign is called the argument of the function, okay? This argument is like its child. This sign doesn't go anywhere without its child. Can't leave it just floating around over there with nobody watching it, right? It has to be with it at all times. You don't just change this child to someone else's child, right? So the argument never changes. The argument doesn't get separated from the trig function. Does that make sense? It all goes together, right? When you're adding things, they're married. When you have arguments of functions, it's their child, right? It's my analogy, I'm going with it, all right? So I saw a lot of people do really weird things, like I'm gonna take away the 2x and the 4x from the signs. I'm gonna move them away. You can't do any of that, okay? The sign of 2x is one thing, the sign of 4x is another thing, okay? So they have to stay together. The only way that I can use my special limits is if I have the sign of something over an x, okay? So the key thing here is that anytime we had more than one trig function, we gave each trig function its own fraction. And then we strategically placed our x's to keep our fractions balanced so that we could then use our special limits. The good thing is that I'm pretty sure that everybody got number 1 right. So we knew what the special limit rule was, which was awesome. That was worth a couple of points. All right, but then once you got here, you had to separate your signs and give them each an x. Now, because we put 1x in the numerator and 1 in the denominator, it maintained the balance of our fraction, so it didn't change anything. Okay? Also, be aware, there was a lot of ridiculousness without limits, okay? You're still evaluating limits here, you need to carry your notation through, okay? In that case, then, this is a special limit whose answer is 2 over 1, and this is a special limit whose answer is 1 over 4. When you multiply those together, you get the 1/2. When you get to number 3, a lot of us knew that we were supposed to switch cotangent to something, okay? Keep in mind that if it's cotangent to x and you split that as cosine over sine, they both get that same argument. Like saying this is a family with a child and now I'm gonna make it 2 parents, they both get the same child, okay? We never change the argument of a trig function, ever. Even as we go through and we create all these derivative rules for trig functions, the argument of the trig function never changes. It's not allowed to change, okay? Once I have that set up, then I want each one in its own fraction, keeping it in its part of the fraction. So cosine's in the numerator, so it has to stay in the numerator. Sine is in the denominator, it's gonna stay in the denominator. All I did was match up this x with this sign. So I put these two together and left this one over here, okay? That's not the only way you could have done this. If you left the x here and you had your sine here and your cosine over here. If you put an x here, then you have to balance that and put one in the denominator somewhere, right? Cosines never get an x opposite, it should always be 1, right? Because that's not special. And then an x here is gonna cause problems for you, okay? So that means the only other place to put it would be underneath this x. Okay? And then take your limit. That's equals to 0. That's gonna work for me because these cancel each other out, right? And I just get 1. The limit of this is 1/2. And when I plug in 0 to cosine of 2 times x, that's cosine of 0, which is 1, and I should get another 1/2. Okay, so they actually both had the same answer for 2. So watch out for that, be aware of that. We did lots of problems like this in the guided practice and the practice problems. There were even a couple on the homework that you had to split up, right? So I was a little bit surprised when I saw some of the work I had back today. Did we just not like underestimated it and just didn't like do a lot of studying or anything, or last week was a rough week, or what was going on? The first thing, we just underestimated and didn't put a lot of effort in. Okay, it happens. Okay. It happens. That's why we want it to happen on the quiz and not the exam, right? So we got to make sure we capture all of those before Friday's exam.
So the exam is this Friday, correct?
Exam is this Friday. Then I had a couple people ask some questions related to the homework that's due tomorrow, when, last week, I don't know which one, but we were talking, someone asked a question about how do I relate the graph of a function and its derivative? And that would go something like this. Okay, so this is what I would call conceptual questions. Do you understand what it means to be a derivative and what that means for the graphs? So for example, if I had a graph where I'm going to draw, let's draw a cubic function. So one that goes down, comes up, and goes back down again. So there's my function. And I want to draw or find a graph, sketch a graph of its derivative. Okay, so over here, I want to sketch its derivative. Actually, I think I'm going to put it underneath because I didn't label it super well. Okay. Now, when I think about derivative and graphs, I think about slope of the tangent line, right? That's the graphical representation of a derivative, is the slope of the tangent line. So if I start to draw a bunch of slopes, the tangent line goes like this. And it's going to turn around and come back this way. It'll jump over here and come back up here. Then it's going to come down. Right? That's if I drew a bunch of tangent lines, that's what they would look like. Okay. Because the tangent line grazes the function in one point and jumps back off again. Okay. All right. Now, the derivative is the slope of those arrows. Okay. So when you look at the pink arrows on the left, are those going up or down? Down. When the slope of a line goes down, what do you know about the slope? It's negative. So that means that the value for my function that represents the derivative is going to have to be negative. So up until this point, it's going to be somewhere down in here. And actually, I think it actually looks like this, if I'm guessing. Okay. It's got to be negative. It's got to be below the axis. Notice this point here, as well as this one up here. Anytime your graph turns around, the slope of the tangent line is going to be 0, right? So that's where it's going to touch the axis, touch the y-axis for the derivative, right here and wherever this one was. Okay. Now, my blue arrows in the middle on the top graph are positive or negative slopes. Positive, so that's going to do something up here. Usually it does something like this, just to guess. And then what about the green ones? They're going down, so they should be negative, which means they're going to be below my axis. So I can use that information to kind of get a quick sketch of the graph. Okay. The key thing you're looking at is the slope of the tangent line going up or going down? And that corresponds to positives and negatives. Okay. Where it turns around is where you're going to get your zeros, where it's going to hit the axis. Okay. So you can use that information to help you on those first couple of homework problems. Okay. Then we had the homework that is due tomorrow, I think, is the one where we're finding derivatives using our shortcut rules, right? Right? Yes. Okay. All right. We finished all the practice problems for those, so you've got the homework assignment ready to go. Hopefully that all goes well. Let me know if you have questions. Do you have questions? No? Okay. So then what I asked you to do between Friday and today was take a look at the next lecture for 3.2 on product and quotient rule. Right? Because if you remember our shortcut rules, we had the power rule, we had the derivative of constants are 0. If you're multiplying by a constant, we can just kind of like let it hang out and just take the derivative of the function. Also, by the way, I don't know if I told you this exactly explicitly, but the verb version of find the derivative is to differentiate. It's not derive, which would be what you think it might be for derivative. If you're finding the derivative, you're going to differentiate a function. So when the instructions say to differentiate something, that's what it's asking you to do. Where were we? Power rule, constant is 0, constant multiple, we just leave it. And then the last one was sums and differences, right? Add and subtract. So for add and subtract, we can just take term by term. But what I didn't list in that was multiplying and dividing, right? Because they're much more complicated. And that's what I went through in the video. So in the video for lecture number 10, you had what we were hoping was going to be a shortcut method, and I gave you a long explanation and proof as to why it's something else. Okay, mainly it's this one. This is our product rule, and I will always refer to it this way. Some people like to do this version where it's F's and G's and this times that and all kinds of stuff. I think it's too many letters and it gets you too confused. Okay, so I stick to 1s and 2s. So I have two functions being multiplied together, function 1 and function 2. And I take 1 prime 2 plus 2 prime 1. Okay, so that's what I have in my head, 1 prime 2 plus 2 prime 1. That's all I need to remember, and I'm good to go. And then I gave you a couple of examples, right? The quotient rule I did not give you a proof of, but it looks very similar, okay? With quotient rule though, we have a top and a bottom. So I use T and B, and I think of it as top prime bottom minus bottom prime top over bottom squared. If some of you have seen this stuff before, some people have other ways to remember this, and I'm gonna let you guys keep that. If you like it, use it. If you don't know it, that's fine too. Okay, I'm gonna stick with tops and bottoms. Top prime bottom minus bottom prime top all over the bottom squared. Okay. And then we went through some examples, and then we went through some guided practice. Okay. Does anybody have questions, want me to go over some of the guided practice, anything you'd like me to do before we jump into practice problems on guided practice 4? Sure thing. This one. All right, so guided practice 4. I know why you asked this one, because putting the square roots involved in quotient rules and product rules can be a mess, right? So here's what we do. This one is division, yes? Because you have a fraction, which means we're going quotient rules. So I'm thinking tops and bottoms here. So that means I'm going to write out the top and the bottom. And when I rewrite that, I'm going to write it in a way that makes it easy for me to take the derivative. So the top is the square root of x, but when I write it down, I want to write it down as a power. So that will be x to what power? 1/2 power. And then the bottom is the 3x minus 2, right? What is the derivative of the top using our power rule? There we go, 1/2 x to the negative 1/2. We bring down the power that's there, so multiply by the 1/2. Decrease your exponent by 1, so 1/2 minus 1 gives you negative 1/2. For the bottom prime, what is that one? 3. Now to put this all together, my f prime of x, I use the quotient rule. So I'm going top prime bottom. So I'm multiplying these two. So the rule is top prime bottom minus bottom prime top all over the bottom squared. The order does matter because you're subtracting now. Okay? With product rule, it didn't matter which one came first, which was your 1 and which was your 2, because you were adding. Okay. Now we're subtracting. So your top prime bottom is those two multiplied together. So it's 1/2 x to the 1/2 times negative 1/2 times 3x minus 2. Minus these two multiplied together. So 3 times x to the 1/2. All over the bottom squared. So 3x minus 2 quantity squared. You never need to multiply out the denominator for me. Don't bother squaring it. It's not usually helpful. Okay. If for some reason WebAssign makes you, then you'll have to, but I think they'll take it as 3x minus 2 quantity squared. Okay. All right, now how do we simplify this? So let's go ahead and distribute this to these two terms. 1/2 times the 3 is 3/2. When I multiply the x to the negative 1/2 times x to the 1, I add the exponents, right? There's a 1 right there. So negative 1/2 and 1 becomes x to the positive 1/2. When I distribute it to the negative 2 times 1/2 is negative 1, so I don't need to write it. And then I just have my x to the negative 1/2 minus 3x to the 1/2 all over 3x minus 2 squared. Now these two are like terms, so I can add them together. So let's see, negative 3 plus 3/2 would be negative 6/2 plus 3/2. So that's going to give me negative 3/2 x to the 1/2 minus x to the negative 1/2 and 3x minus 2 squared. If I want to make this pretty, here's what I would do. If I want to get rid of that negative exponent, I'm going to multiply the top and bottom of my fraction by x to the 1/2. I also want to get rid of the 2 that's in that fraction in the first term. So I'm going to multiply by 2 as well, top and bottom. When I do that, I get negative 3x minus 2. And the 2x to the 1/2 just goes on the bottom. If you want to pull that negative out front, you can and make them both positive, but you don't have to. Yes. No negative exponents. You got to get rid of fractions and fractions, and you got to get rid of negative exponents. That's fractions and fractions. Two things you got to get rid of are you can't have fractions and fractions, and you can't have negative exponents. Those are my rules. Okay. Almost anything else will fly. Okay. But that's an example of how our quotient rule works. Just so that everybody's on the same page, let's run through a quick product rule one. You want to do the one with polynomials or the one with the square root? One with the square root. Okay, let's look at number 2. All right, when I look at this, I am multiplying two things together. I have function 1 right here, and I have function 2 over here. Doesn't matter which one you call which. But that means I'm multiplying them, so I'm going to use my product rule. So I know that I need 1 prime 2 plus 2 prime 1. Okay. All right, so function 1 is going to be the square root of x plus 2. I'm going to rewrite the square root of x as x to the 1/2 plus 2. Function 2 is the x cubed minus 7x plus 4. Then I need each of the derivatives of those two functions. So 2 prime is the derivative of function 2 is going to be what? And it is 3x squared minus 7. One prime is a little bit trickier because that 1/2, but we're seeing it a lot here, so that's good. We bring down the 1/2, leave the x, the new exponent, we subtract 1. So 1/2 minus 1 is again negative 1/2. The derivative of the plus 2 is 0, so I don't need it. So this is my setup. When I put it all together to find my f prime of x, I need 1 prime 2. That's these two multiplied together. So it's 1/2 x to the minus 1/2 times x cubed minus 7x plus 4. Plus these two multiplied together. So 3x squared minus 7 times x to the 1/2 plus 2. It's always your setup. I always set it up in the same way so that I can use the visuals and the organization to my advantage. Right? If I always set it up the same way, then all I'm doing is kind of multiplying the two things on the diagonals and adding them up. With quotient rule, it's the same thing, only I have to start with the top prime and I subtract them, and then I have a denominator. Now we want to go ahead and multiply everything out. So that means I'm taking this 1 times the x cubed. That's going to give me 1/2 x to the 5/2 minus times this one 7/2 x to the 1/2 plus 2 x to the negative 1/2. Then we'll FOIL the second expression here. So you're taking the 3x squared times the x to the 1/2. So that's 3x to the 5/2. The outside is going to be plus 6x squared. The inside is minus 7x to the 1/2. And the last is negative 14. Then I'm looking for common terms, like terms. So I've got a 5/2 term. I've got a 1/2 term. And that's it. So when I combine the yellow ones, 3 plus 1/2 gives me 7/2. X to the 5/2. Then if I'm going in descending order, x squared would be next. So plus 6x squared. Then my blue terms I can combine negative 7/2 and negative 7. So negative 7 would be negative 14/2. Where was I? Minus 7/2 is negative 21 over 2. So that's minus 21 over 2, x to the 1/2. Then I get minus 14. And then the last term is the 2x to the negative 1/2. So plus 2, and a negative exponent means it moves to the bottom. Okay. When you're adding it, it only goes below the number that's in front. It doesn't go under everything. A lot of people have a tendency to draw me a big fraction and put that x to the 1/2 underneath everybody. But that doesn't work because it's the x to the negative 1/2 is only being multiplied by that 2. It's a separate term, so it only goes there at the end. So this is the final answer that we're looking for. Okay. Questions for me? All right, let's go ahead and jump into our practice problems and start working on those. So you're here. Find some friends. Yeah. What's up?
I'm having trouble understanding. Would I just keep it 2 here because you multiply an x to the
Yes.
So it's 0x.
Correct. Because you're adding the negative 1 and the 1, and you get 0, and x to the 0 is just 1. They're going to cancel out. X squared plus And Xander, I did verify. Xander, I did verify. I do believe that what's in my notes does mean that you are a dual enrollment student.
Sorry, I keep coming in late. It's because I'm a computer, so like it's.
Yeah.
I multiply everything. I multiplied it and then I didn't do Yeah, no, I can't see that. The only way to go into 1/2 is when you see square. So you're gonna change this as well.
How did you do here?
So I got 15%.
I actually played again.
There's no way. You remember it? You know how to write it down?
Yeah, that was kind of a great moment.
Yep.
It was our team. I just have a condition myself.
If you want the video. Hearing that, you're putting
Yes.
That's remember where I was at for those. I didn't know my boss.
Where's your boss? Oh, you saw it. I'm confused. Wrong. I have seen this. Two bites there. And then you just.
Yes. Now, erase all this.
If I'm gonna do it, you tell me it's wrong.
Now you're erasing.
No, because I'm about to get it.
What's the report?
Yeah.
How do you?
So. they're on the
Overtime.
Take
Number in front, so this X is over here, and this, what's our rule?
that is
What's our rule? Yeah, multiply by the x bar, decrease the x bar by 1, right? So you do that
Oh,
L
so I
here.
did something else too, I forgot.
Here, you're going to bring down the 2.
When you add those together, plus. And four.
Your function 2 is right, so we write that.
So it's like, instead of 2x, then you should get 8x. 2x and 6x have a constant.
Oh, you have us, you do it.
Yeah, that's my mistake, I forgot about that.
You're gonna bring this number times this number together. The answer is gonna be what?
Oh, was that? No, that's a tree, that's not a.
X, yes,
Ah,
and then
I have
the
that.
four is, it's just the number in front of the.
That was the
So
book.
you just-
No, they do. Multiplying it, that's a different one. But adding them together.
Now your pieces are right, now you use your rule. Your product. Make the erase on this. So now all of this is right. Yes, 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 So this is G, this is G prime of X.
And then you, so that's. Yeah.
Yeah, we'll get that.
What are you talking about?
Tell me about how you got this. Was that like almonds?
Over 2x squared.
No, you're right, you're right. Yeah. First of all, that one. Yeah, no, that's what we occurred. Okay, now, careful. Should go start with the top right. So these two are gonna be on sides. So you're gonna get the opposite sides. Okay, we got the same. This one positive. Top right bottom, minus bottom right top. Bottom right top. Yes. Otherwise, it's it is, yes. That was it. So that is the derivative of what? Right, so you're gonna label this as top prime. The derivative of the top.
Top line.
And then you gotta, yes, there you go, put it within your quotient, that's your top prime. Like the multiplicity, like this one x squared. Negative x.
Not special.
You don't even have to. You don't even have and then this between.
Oh, you saw it?
Yeah, I'm sorry.
Are you still, did you guys?
No.
Hey, wait. Let me see what you. Make sure. Did you guys? Oh, you still. Still on it?
Yeah, but I'm not sure.
So. This, you wouldn't put that, it's just for it. Yes. Because five is not having.
It's not that bad.
was boiling out, it's the same exact stuff. She's like,
I'm good, this one, I'm good.
I'm worried about. It would be just B squared. Oh, you factored it out now? You bet D prime. Oh, yeah, no, that's.
We're supposed to take the 4x out.
Yeah, really it's just like. Two, I got two left. No, you don't. It's like the bottom. It's like an option. I don't know, let's hope that. Like 7.2 or 7.3. Yeah, the first one when it has like the function. Yeah, I just feel like at the end you have two like the
That's all I
Yeah, that was the problem. Yeah, there was no, I'm just thinking of modules. So that was kind of like where should we go this year? So this one I like, but it's also like very. Very small. That's your favorite. Did you know? Yeah. It's like something ridiculous. I mean, like a small like cartridges or ounce. Yeah, and those are like $10. 10 or probably $50. Sure. Dude, no. You're right. I'm sorry. I showed some. Or maybe have that off.
If you are getting pleased and you're all done, you can go and grab our next set of notes with our friends. I can bring back. Alright, if you have to grab the rest of the copies off the copier, we'll see you in good old time. But, game plan. We're gonna come in tomorrow, we'll finish up these problems and go over them, and then we're gonna start it on the next section, with the notes you're getting up there. That's from section 3.4. Skipping 3.3, we'll come back to it in a little bit. I'm doing section 3.4 first on change roll. So between today and tomorrow, and you take a look at the lecture video.
How you feel? I got like, I don't know the exact, like the final score is 7. But you got the points, and then on the last one, right, wrong. And it's -8. So none of those points offered, no points. Like after, I'm not usually studying in the library, really early, but I heard that third. Something like that. But you could have like cybersecurity. We did it last week. Well, we didn't. He wasn't there, but me. Did you come back? Yeah. No, I do. So the game when I study, go home, sleep, maybe set on, I guess. How did you do on the Instagram? I got well, my first school was my second one was yeah, I got a 13. No, yeah, the second one I was really hungry, honestly. So I heard
Anybody who's got like a 10-year track like here for a long time, you have to have a term, what they consider a turnaround degree to be a 10-year track, meaning like your permanent battle.
oh, like
Yes.
I don't know if I envy that, but it sounds impressive. Well, you go for that.
It means that I will apply to get a promotion to the next level. So when you come in, you're, with no experience whatsoever, you come in at the assistant professor level. After 5 years, you work for 5 years, in your 6th year, you submit a portfolio and says, here's what I've done over the last 5 years, and you apply for tenure and promotion to associate or assistant. And they look at your teaching, your service to the department and the university, and your research. And then, God, I wish. I wish with the promotion I didn't even end up at 6 years. And then after another 5 years, then you can apply to go up for your last promotion. So I've been here 13 years, so I can go up for promotion to full professor in February.
Well,
So that
you
means
are
stuff.
definitely experienced.
Just means they can't fire me unless they have a really, 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 really good reason. Like I've got a lot.
We're gonna run.
Yeah, like you can't just like, oh, I didn't come to class 2 days ago. You can't do class whenever I want. You can't fire me for that yet.
Yes.
There's like a process, right? You gotta do that a couple of times.
You always get solid 10.
Not like, doing something inappropriate as opposed to the story,
Yeah.
but like.
Keep your eyes on the prize, not just the
I emailed you about. Yes. Did you have an idea what they were thinking?
Could it, like, Wednesday?
Yes,
Does that work?
fine.
I'd like, I don't know, you said 10 to 12 minutes, like, I'll come in 10 if that's.
Whatever works, I'm just hanging out for 2 hours, so
Okay.
it should only be a, 10 to 20 minute quiz.
Okay.
So, but yeah, you can send me an email and just say, here's when I'm planning to come, that way I can push in my calendar and know what to expect.
Okay, perfect, thank you so much. Appreciate it. Thank you.
Is there a thing here for the
You want a
holes?
stapler or a 3-hole punch?
3-hole punch.
Right here,
Oh,
right here.
awesome, that's awesome. So, I'm really, last homework that was doing yesterday.
Yeah.
Last homework, are there gonna be like a lot of questions like that on the field?
Like what? When you say like this.
Like, where you're gonna want us to, use the definition of the.
There will be one,
Okay, because like that would take a while.
yes. Why we do it once,
Yeah, because I definitely.
so that I know you know what it means,
Yeah,
then we move on.
I kind of, like on the homework, I did use the shortcut rule on them, just kind of like, so I had an issue where, for some reason, I was trying to submit my answer,
Mhm.
but it said cannot understand, it was like a syntax error. on the
So, did it involve intervals?
Yes, but this is what happened.
I can tell you why it's doing that.
Well, wait a second. Intervals.